Okay, so I've had a little bit of trouble trying to get this video working, so hopefully everything's okay. So I'm just going to touch on a couple of subjects in one of my lectures. I'm going to upload this presentation, so if there's anything else you want to learn about that's in this, I will be more than happy to help. So, okay. Now, what is the best accomplishment made by the cypherpunks? Now, we talked about this in our first homework assignment. So you might know that it's the creation of Bitcoin by Satoshi Nakamoto, but there's so much more to it, right? So they their whole goal was to protect the network, because our network, the protocols that are set up with our network, it's not made to secure the network. So if you're sending a message along, like, there's nothing to secure it. Anybody can go in and look at it. So they invented the use of cryptography to send emails, to what we use a lot of encryption for nowadays, on the network and everything. So that was their goal. And part of all of that was also securing cache systems. So the one thing they created and started working on since the 80s is the electronic cache systems. So let's see if I can change slides here. Okay, so Bitcoin was the one that came out in 2008 during the bailout period that actually made the biggest impact. Now, there were a bunch more that were created, but they were all stopped by the government. There was a huge impact on a lot of people that had tried to do this before, and that's why Satoshi has remained hidden. So, what is their biggest ideology with cypherpunks? It's that privacy is really important, and their manifesto says how. Their manifesto, privacy and not anonymity, is okay. We, the cypherpunks, are dedicated to building anonymous systems. So privacy and anonymity. We are defending our privacy with cryptography. Okay. So their main skill set was to defend everybody's privacy by using cryptography. So we see that in the electronic cash system. What makes Bitcoin Bitcoin is how cryptography is used. Okay, that is like the main building block of Bitcoin core and blockchain, essentially blockchain. Okay, so what makes blockchain different from any other database or anything else? Cryptography. That is it. Cryptography. And I'm going to touch on that a little more. Okay, so let's talk about what Bitcoin is. So we talked essentially about what's the difference between Bitcoin and blockchain. So here's a little visual, right? So Bitcoin is an electronic cash system. It's like software. In web development, you may have heard of the front end, which is what you see when you're on a website. And then there's the back end, the area that holds all the information, or the database, right? So when you're logging into a website, the software, you click on the software, the front end software, and then it sends a message to the database like, hey, does this password combination work? And then it looks, and then it comes back, right? So blockchain is that database that's connected to Bitcoin, right? Blockchain is that ledger that holds all the different transactions. So when you bring Bitcoin and blockchain together, what you come up with is the Bitcoin core, okay? That's what it's called. And if you want to get on GitHub and see all the code, it's all open, it's all out there. How everything is set up is all right there for you to look at. Okay, so let's talk a little more about the blockchain, okay? Because that's the really important part. You can add any coin to a blockchain. So, blockchain is made up of cryptographic algorithms, and there's 5 main ones that make it so unique in what it is, okay? And I'm not going to go into detail about all of these algorithms, but I just want to say SHA-256, okay, that's used a lot in mining, okay? When you hashed with SHA-256 in your assignment. RIPE-MD160, that's used as well, because a lot of these algorithms are very complicated and have a gazillion steps, and one of those steps uses that hashing algorithm. So it's just like SHA-256, just a different one. elliptical curve cryptography, that is used for random number selection. And that, again, that's a part of making the private key that you have harder to guess. Okay. Merkle tree hashing, that is used. So let's say you want to, it's the final check and validation to make sure that nothing has changed in the blockchain. So people say, okay, it's a database that's really secure. There's no way that somebody can go in and change a value without changing the entire blockchain. And Merkle tree hashing is that validating mechanism. And the way it works is it goes through a certain level. Okay, so let's say you want to say, okay, when did this transaction happen? Did it happen, right? You don't have to go into every single block and look at it. Merkle tree hashing has a way where you can sort through and find it much faster. Okay? And hash cache. This is what answers the mining question, okay? This hash cache is how mining works. So let's talk about that. So hash cache was created by a man who wanted to stop spamming, okay? So back in the 90s, we didn't have any kind of prevention technique. People would just get tons of spam. And then on the other side, one person could send a million messages out like in a second with zero effort, really. I mean, zero. So he wanted to make it a little harder for them to send each email. So he wanted it so the computer had to work to send each email, preventing this person from sending a billion emails, right? So that is called proof of work, okay? Using the resources of that computer by using game theory, okay, to make the computer solve a problem in order to do the work, okay? And in this case, it was to send the email. Now, in mining, same thing. To add a block to the blockchain, this mining computer is going to have to do a lot of work. So that's basically what these mining computers are constantly doing, churning away at these hash algorithms. So when you did that hash, you did that manually, you just kind of figured it out, or you clicked a button and it did the algorithm for you, right? So a mining computer will do that a million times to solve a certain puzzle. So what puzzle is this mining computer solving? Okay, so the mining computer is given a challenge. Okay, so when you do a hash, right, you ended up with a 256 character string. Now, you'd probably remember if it had like 17 zeros in front of it, right? Like if it looked a specific way. So the challenge is normally a number of zeros. You have to take this character string and keep hashing it with a random number. This random number is called a nonce. And you just keep churning away at it with different random numbers, right? Until you get a 256 character string with a certain number of zeros on it, the challenge number. So it will say, okay, in order to add this next block, you have to solve this puzzle and end up with 40 zeros in front of your 256 character string, okay? And the more number of zeros you have, the harder it is to solve. So that's how that works, okay? And the first mining computer that ends up with that number gets to add that block. And when they add that block, they get awarded that Bitcoin. So let's talk about what a block is, okay? So a block is a whole bunch of transactions. So these mining computers do a lot more than just that game. They're also processing these transactions, okay? So first, what they do is they process enough transactions for it to make up a 2 megabyte block, okay? And once they have that block of transactions, and these transactions, it's just metadata, it's just a whole bunch of encrypted character strings to make up 2 megabytes. So there's a whole bunch of transactions in one block. And then the next step is to play that challenge game until they add that block. So that's how mining works. I hope this helps.